Welcome back to the VitAlphabet. This time we will be going through the 8 vitamins included in the B complex. Before we get started, I just wanted to say that I will be going through these kind of fast, not only because of the sheer amount of information, but also from the similarities that they all share. Now, without further ado, our first B vitamin, vitamin B1. Also known as thiamine, vitamin B1 comes in the form of crystals that are soluble in water, making it a water-soluble vitamin. In fact, all B vitamins are. As we look closer, you will see the chemical structure of thiamine. Thiamine is composed of an aminopyridine and thiazyl ring connected by a methyl bridge. Branching off of those are the methyl groups, amino group, and hydroxyl chain. But vitamin B1 doesn't really exist in its free thiamine form. Instead, they are found bound to phosphorus groups. If there's one phosphorus group, then it is called thiamine monophosphate, and if there are two, then it's thiamine diphosphate. Simple enough. There is a problem though. We cannot absorb neither the monophosphate nor diphosphate version. Good thing for us, our body cleaves the thiamine free of their phosphate friends with the help of phosphatases found in the intestines. The free thiamine is now absorbed into the lumen via active transport, or through passive transport if there is a high enough amount present in the body. Once in the body, the thiamine is reconverted to thiamine diphosphate, the most common and biologically active form of vitamin B1. Its job is to act as a cofactor for enzymes. To put it simply, cofactors bind and assist the enzyme in a reaction. TDP is actually a cofactor for 5 different enzymes that break down carbohydrates, act as antioxidants, and synthesize pentoses, which will eventually become a part of DNA and RNA. Overall, the interactions aid in the growth and development of cells. These cofactors can be recycled, but vitamin B1 has a short half-life and can only be stored up to 30 milligrams, so your daily intake will still be on the higher side. The recommended daily amount comes out to 1.2 milligrams. But there is something missing. There is no upper limit. There isn't a way to determine an upper limit because there is no complications due to high concentrations of vitamin B1. You will see that many of the B vitamins do not have an upper limit for this exact same reason. Also, B1 absorption decreases rapidly with high doses, so even if you do take a bunch of thiamine, most of it will just pass through your body. Of course, I'm not saying slam down the B1 supplements, just use your common sense. Going from one extreme to the other, a lack of vitamin B1 will definitely give you some trouble. Vitamin B1 deficiency, also known as beriberi, may affect the nervous system, causing poor motor function, or the cardiovascular system, resulting in fluid retention and tachycardia. Or you could get the worst of both worlds and have both systems affected. The best way to prevent beriberi is to take enough vitamin B1. This can be done through medication, vitamin supplements, and food. For the most part, our food contains enough vitamin B1 for our recommended daily amount. Grains have the highest concentration, but due to the way that they are processed, most of the natural vitamins are lost. To combat this, food companies enrich or fortify their products to restore what was lost or add additional vitamins and minerals that weren't originally there. Rice and egg noodles rank highest in unenriched vitamin B1 foods, and if you're looking for a meat option, go for pork chops. And just like that, we're on to the next. This is vitamin B2, riboflavin, a yellow-orange crystalline powder. Riboflavin contains a benzene, pyrazine, and pyrimidine ring, and a ribosyl chain. Like vitamin B1, vitamin B2 must also be in its free form to be absorbed. Most riboflavin is either attached to a protein or in one of its biologically active forms. In digestion, the flavoproteins will be cleaved to the protein aspect, freeing the coenzymes flavin mononucleotide or flavin adenine dinucleotide. We still have some work to do because these aren't riboflavin yet. FAD will lose one of its nucleotides with the help of FAD pyrophosphatase, and then again with FMN phosphatase to remove the remaining phosphate group, leaving plain old riboflavin, which is then absorbed like vitamin B1, active transport at normal doses and passive transport at high doses. The dissolved riboflavin then moves up to the liver, where it can combine with flavokinase to create FMN, and if needed, FAD synthetase to create, well, FAD of course. FMN and FAD are coenzymes that can stain the liver, but they are also found in the spleen and small intestine. They help with metabolizing carbs, aiding in growth and development, and acting as antioxidants. Sounds a lot like vitamin B1, doesn't it? But in addition to that, they also help create new blood cells and antibodies. Separately, they deal a lot with the other vitamins. FMN converts vitamin B6 to its active form, and FAD helps produce vitamin B3 and the activation of vitamins A, K, and B9. So that means that lacking these coenzymes will create a domino effect on the other vitamins. Speaking of lacking vitamin B2, a vitamin B2 deficiency will cause the skin to become dry, itchy, and scaly. Around the mouth, the corners will begin to crack, and the lips will have a burning sensation, and the eyes will become red, itchy, and have excessive tearing. Most of these problems are due to the lowered amount of antioxidative activity from the vitamins. The body will experience more oxidative stress, resulting in cellular damage. Aside from the oxidative stress, a lack of production of red blood cells will bring on anemia and the symptoms that accompany it. Luckily, deficiency is rare due to the abundance of vitamin B2 within our food. The best way to get vitamin B2 is to consume beef products, mostly liver, dairy products, and almonds. We can synthesize this vitamin with the help of bacteria in our intestines, but whether we actually benefit from it is unknown. If we look at the daily values, again we see that there is no set upper limit. If we do take too much, the body will just excrete it in urine, and because riboflavin is yellow, it will make your pee the same color as it, but that's all. And then there is the daily amount, which amounts to 1.3 milligrams. You see that? That powder right there? I'll give you a minute to guess what it is. Okay, time's up. It's vitamin B3, niacin. It has the simplest structure of all the B vitamins, just a pyridine ring and a carboxylic acid, which is also the reason that niacin can be referred to as nicotinic acid. Vitamin B3 has two coenzymes, nicotinamide adenine dinucleotide and nicotinamide adenine dinucleotide phosphate. In order to utilize these coenzymes, we must first absorb them. In digestion, NADPH is hydrolyzed by pyrophosphatase in order to become NAD. The glycohydrolase converts NAD into nicotinamide. Nicotinamide is able to be absorbed into the intestines, which also happens to be the most abundant form of vitamin B3 found in the body. We already discussed the other form of vitamin B3, nicotinic acid. We can actually produce this molecule with the help of the amino acid tryptophan. Both variations are able to be converted into NAD and NADPH in the liver. Tryptophan will create quinolinic acid, which will convert into nicotinic acid mononucleotide with the transfer of a phospholipase. And adenylate and NAMN will produce nicotinic acid adenine dinucleotide, which will bring us to our final step. The nicotinic acid in NAAD will be converted to nicotinamide, resulting in getting rid of that little A and leaving us with pure NAD. To get to NADPH, just throw NAD and NAD kinase together, and you'll end up with the NADPH. Oh, what do NAD and NADPH do? Well, they're pretty important coenzymes in cellular respiration, which helps create energy from glycogen, lipids, proteins, and purines. They also work as anti-hyperlipidemics by increasing lipoprotein lipase activity. Lipoprotein lipase is an enzyme that reduces the bad cholesterols, both very low and low density lipoproteins, and increases the good cholesterols, the high density lipoproteins. Say you don't get enough of vitamin B3, what you'll be suffering from is pellagra. Pellagra is a potentially fatal condition that affects the skin, nervous system, and digestive system. Symptoms include dermatitis, lesions, memory loss, insomnia, nerve damage, and vomiting. To avoid a deficiency, it is recommended that you consume about 16 milligrams daily, which also happens to be our highest required amount for all B vitamins. But be careful with this one. Unlike the others, there is an established upper limit. That limit comes at 35 milligrams. Take too much and you'll experience flushing, tachycardia, diarrhea, gout, and itchy skin. But like the others, in order to get enough of this vitamin, you'll need to eat. The highest vitamin B3 foods are portobello mushrooms, cheese, poultry, and liver. Alright, I didn't give you enough time to guess on the last one, so I'll let you guess on this one. If you thought it was vitamin B4, then you'd be wrong. It's vitamin B5. pantothenic acid. There is no vitamin B4. As you can see, it looks something like olive oil. Well, I did use olive oil for the picture, but that's against the point. The point is that pantothenic acid is yellow oil, a thick one at that. Looking at the chemical structure, it doesn't look like olive oil at all. Pantothenic acid is formed by two molecules, pantoic acid and a beta-alanine. But to get to this point, we must start from the beginning. In food, pantothenic acid comes in the form of coenzyme A and acyl carrier proteins. These two can be hydrolyzed into phosphopentathene, 4'-phosphopentathene to be exact. After the body cleaves the phosphorus group, it creates pentathene. It just needs to be hydrolyzed again to get our free pantothenic acid. Now the vitamin can be absorbed, with the same rules as the last three. Once absorbed, the body does the same thing, but in reverse. Pantothenic acid is built back up to coenzyme A by a 5-step process. I won't explain it, but that's the process. See for yourself. So, we are back where we started, but now we can utilize these molecules. Your friend coenzyme A will grab an acetyl group and donate it to the Krebs cycle, one of the main sections in cellular respiration. The acyl carrier proteins will mainly deal with the creation of lipids with the help of CoA and NADPH. Vitamin B5 also functions as an antioxidant and aids in the synthesis of neurotransmitters, steroid hormones, hemoglobins, and growth factors. With the lack of vitamin B5, the symptoms primarily deal with neurology, hand numbness, headaches, fatigue, and difficulty sleeping. Moving on to our amounts, it's recommended to have 5 mg daily. Good ways to get that much is to eat shiitake mushrooms, sunflower seeds, and you know what that one is. Beef liver, of course. There is no upper limit for vitamin B5, but there is still some complications from taking too much. That being said, the symptoms, if any, are mild. Mild diarrhea and some gastrointestinal distress like bloating and cramping. Alright, I feel like this episode's gone on long enough. I'm sure nobody wants to watch a half-hour video on vitamins, and I certainly don't want to edit that. So we'll split it. We will discuss the final 4 B vitamins in the next part.